Okay, welcome back. And this lecture is the D30 International Program in Nagoya Universities. And today's lecture is the 8th lecture named Triangle Waveform Oscillator, second version. The last lecture is triangle waveform oscillators phenomena, operating phenomena. And we can analyze and understand why we can obtain the triangle waveform from this circuit, electric circuit. Okay, and we can understand repeat alternately this circuit and this circuit repeat. So we can obtain the triangle waveform. Charge, discharge, charge, discharge, charge, discharge. Repeat alternately the two equivalent circuit. This circuit and this circuit, because of the voltage, output voltage, the comparator's operation. Comparator's operation output voltage is only the two value, power source value or ground value. Okay, so we can indicate that this circuit ground line, power source is the ground line, and 15 volt, the input port. Okay. So this is G30 for the G30 student report answer this lecture. So this is the Christmas gift for the Nagoya University student. Okay. The pandemic influence, so you must stay in your room. So I will be Santa Claus. Okay. So please check this movie. ではやりましょうか。Okay. This in the report, the boost choppers switching frequency. This switching frequency is our order is 10 kilohertz. Please design the 10 kilohertz switching frequency in case of this boost chopper. You know, already we have mentioned in the PWM control lecture. This switching frequency decides this triangle waveform. These triangle waveforms timing the TS is frequency decide this term. Okay, and this term repeat alternately. Okay, and if you obtain this term, if you invert the TS, you can obtain the switching frequency. Okay, so we must analyze that each circuit using theいつだったかな fifth seven じゃないな fifth fourth or fifth lecture in the transient phenomenon. Okay, and in case of the 1. Let's analyze this term. In this case, this formula, we can obtain the VCT equal includes this line, dot line. You can already write easily in this. You can obtain the formula, okay? And this time, this rise VCT equal okay, easily we can obtain it. If you cannot obtain this formula, please mention and please check the movie, fifth or sixth lecture of the transient phenomenon. So, and using this formula, we'd like to obtain this term, TB, first TB, and later we'd like to obtain TA, and TB minus TA, we can obtain this term. This term, we can obtain this term. And in case of the TC, obtain this term. Added each term, we can obtain TS, and we can obtain the switching frequency. Okay. So first of all, we'd like to obtain a TB. In case of the TB, このまま書くと TB's value means 10 volt. So VCT equal 10. The time is the TB. So 10 equal TB. And you can obtain the TB. Very easy. Easy なのかよ。ちょっとやってみよう。めんどくさい。なんぼや。準備してなかったな。ごめんね。めんどくさいな。ちゃんと書くか。途中飛ばしたらかわいそうやな。お腹がすいたよ。 こうなのかな We can obtain this formula. This is a TB, and you can obtain the same TA. You can obtain next TA. And please calculate this one. And finally, we direct obtain this terminal T. こっちこっちここT1 にしようか T2 T1 you can obtain that これやったとほんまかい忘れたけど多分大丈夫 This one and T2 is the equivalent circuit difference and this one first is the 10 so the 5 voltage point is the TC in this equation. So you can obtain the you directly obtain the TC equation is here. TC and the TC. So TC じゃない T2 か T2 だね T2 you can obtain the T2 you can obtain TC in this case TC means this one but the T2 にしようか term T2 is here okay so if you direct obtain the switching frequency of the booster path you can obtain the TS inverter and can obtain the T1 plus T2 で汚いなこれ This is the switching frequency. And your design, the real design, you have already obtained this order, 10 kilohertz. So you input this 10 kilohertz. And design means RCTC. This RCTC is this value RC, RT, and CT. You must design this value. If you design this value, you can obtain the 10 kilohertz. But you already 10 kilohertz is ordered. So you must design this one. However, in the comparator, for example, the comparators, 消していいかなマイク。comparators, imaginary short, こっちだろう。マイク。comparators, imaginary short resistance. the value is infinity in the but you have already taken from already run the textbook the value is infinity, but real one ideal the value is around 10 mega ohm over. And near this term, near connected this value is around 1 over 10 times resistance value. So the minimum is here. So we are 1 megahertz, 1 mega, 1 mega ohm over. So the minimum value is here. So the 1 over 10 times value is 100 kilohertz, kilo ohm. Usually, this is a electrical engineering know-how. The manufacturer's IC is remained some resistance, big resistance, but not infinity value. So that usually we have input here. So if you use this value, we can ignore, we can treat the like a textbook. We can treat this resistance to the infinity. Okay. This is the know-how. If you construct the electric circuit, and we will mention some know-how of これ言うと答えになるな。Okay. In the G30 student, for the G30 student, I have the one point for the construction of the electric circuit, the experimental circuit. In the real one, we require the pull-up resistance for this for operating this comparator. Please consider why we require this pull-up resistance. Please consider and please write your report. I have already mentioned the answer, so please consider this additional report. Okay? For protect the comparator. For protect. 俺答え言ってるね。This is the answer, but please consider. Okay? Okay. This is a triangle waveform oscillators. How to design the triangle waveform oscillator? From our know-how, we have automatically determined this value. So only we can arrange this value from this one decided. So we can obtain the CT value. Okay, this is how to design the triangle waveform oscillator. Okay. Next is the last basic course of the power electronics lecture. Okay? See you next lecture. お疲れ様でした。